Yeah, here we are again in the workshop. Currently doing some peck drilling. I'm making some T-nuts. What you see has all been done using the conversational programming in Pilot. And I've already spot drilled these using a mill drill just to see how that cycle works. That's been fine. As you can see, the milling went well off the material stock. Currently just spot drilling, well, peck drilling right through the bar. It's that sounds like it's just gone through the full size, so that sounds pretty good to me. And we'll just let it carry on. I'll just leave this running. As you can see, it's a lovely cycle. I really like watching the peck drilling cycle working. You'll hear it come through the work, and then it should move on to the next hole. All automatic. Brilliant. Love it. Here we go. Almost through, are we? Soon to go through. That's it, through the material. Got one more peck, just to make sure it's fully clear. And then it'll move on. Here we go. How's that, folks? And still got one more hole after this to do. It's the first real steel component I've made. Been playing around with cutting some sprockets in steel, which failed miserably. But since I got Pathpilot installed and I've got the much more control over the machine, I've been able to do a lot more with it. It's just absolutely lovely piece of software to make the machine that much more user friendly. It's incredible, really. I should be almost through this one. Another cycle maybe. Very conservative. I like to stick conservative with my speeds and feeds. No point in wearing tools out. I'm not in production, so not yet anyway. But there we go. There's the last hole. The reason there's two holes there, I'm going to make that. These are T-nuts, but that last one I'm going to make into a machine stop, so that I'll probably make two of them eventually. Maybe make another one out of the stock that's left, just so you can locate work on the table much easier. Okay, that's it for now. Next time I'll be trying out the thread milling. Okay, back again. Here we are doing some thread milling. It's very difficult to see what's actually happening here, but basically, if you look close enough, let's get zoomed in as close as I can. You will see that the thread mill is putting a thread, or it's about to start. I think it's maybe a little bit clearer of the thread, but one thing I need to check is how far it's got to go. Oh, we're okay. We've got sufficient clearance under there. I forgot about that when I put the back again to thread cutting. You'll hear a rather loud noise as this gets to the bottom. Basically, it's just touching the taper of the thread cutter itself. There we go, and you can just see it generates a little bit of heat, but it's not doing any harm, so I'm going to leave it. I don't think it'll do any harm. It's clear of the bottom of the work. It's forming a nice little polished countersink anyway, looking at it. And I can see the thread there that it's cut. Doesn't look too bad. I'm trying to focus on it. It just doesn't like to focus on that. Well, I can see it there. It doesn't look too bad. Probably need cleaning out with a tap. I'm just using an insert end mill, two cutters in an insert mill, about 0.61 inches diameter. And I'm facing off the top of the stock down to the desired depth at this point on the T-nut. The finish of this thing in parts is really nice. It's a good finish. I did try using the fly cutter, super fly cutter, but I couldn't quite get it to do what I wanted it to. Something to do with the diameter of the tool that I put in for it. It's probably too large, and it just didn't like it at all. And rather than risk damaging the tool, I took it out and rejigged the program to run this cutter. Okay, here you can see we're cutting off the T-slots. I'll do one side and I'll flip the part, and once I've flipped it I'll leave about 15 thou of metal remaining between the cuts, just so that when I break them off they don't, or when I cut through, I don't get them jamming up the cutter and breaking the cutter basically. I'll show you what I mean when I finish. Okay, well here we are, getting on quite well with these T-nuts. The job I'm doing now is just slotting the top, so I just peel these off, you know, by breaking the metal between the slots. There's a slot on the underface. They're lined up perfectly with each other and they look pretty good. In fact, that one there is completely through, which is brilliant. It's what I wanted to happen, but it's really good. I can see, you can see where it's gone right through. You can see a join line, but that's probably only a thousandth or a couple of thousandths of an inch, which isn't going to bother me. Not for. Okay, well that's the camera switched on. I'm just going to show you how easy it is to program one of these slots in. When I did the top face of it, I marked the position of my Y coordinates for each slot, because you can't see it at the moment. The bar with the T-nut on is set transversely across the milling table. Obviously I'm just using a quarter cutter, or sorry, a 6mm cutter to cut the slots. I don't want it to move anywhere, so the first thing I do is in Coversational milling. This was a previous slot. It starts at X, that's with the cutter right against the side of the work. It travels along to X end, and that's with the centre of the cutter just past the start of the work. Now for Y, under normal circumstances this is used for surfacing, so it would continue around in decreasing circles by the amount of step over you give it. If you put 0 step over in there and you give it a Y coordinate which is fixed at one end and the other, then it's just going to go in an X direction and cut the slot the width of the cutter, and that's basically all it is. So I take my coordinates that I took from the first slot. I'm doing slot number 4, which is minus 5.2216, and here we go again, minus 5.2216. Enter it and then post it to file. I'm just going to call it the top slot again, top slot 5. Hit the enter button, and there we go. Along the top there's our top slot 5 T-nuts, and I can more or less start the machine straight away. I know that it's quite happy with it, but one thing that I do like to do is just put it in single block, just to make sure there's nothing stupid going on with me. And you know, I'm quite prone to making mistakes, so I'll do it in single. That's a nice thing about this Path Pilot. I'll do it in single block, and you'll see. Right, we should on coolant on. There we go. Spindle on, and it's going to go to the coordinate where it needs to go, and it looks pretty good so far. I'll carry on down. If I pan around, if I can, goodness me, that's tight. Hopefully you should be able to see the machine. There we are, and it's stopped in a safe position, and I can see from here straight away that everything's fine with that. bring my max valve up to 100%, top off a single block, and then hit cycle start, and off she goes. And that took very little time. And that's it, cutting that slot now. It's cut there for that one, but there we go. And it's got 20 passes to make, and that's the end of that slot. And it's very, very easy, very intuitive. You get plenty of prompts on screen if you do anything wrong, so keep it going. Okay, if you can hear me above the noise of my compressor, there you see the 4 T-nuts. I've just broken them off the bar just by bending them between the gaps. You can see there it's an extremely thin piece of metal that's actually, if I can get into focus, that's actually holding them on. I just did that by line of sight from the bottom of the milling cutter when I set the Z axis or the Z depth for the cut, and it worked fine. I stopped the program short for this one because this little piece of metal was overhanging the vise, and if you have anything like that overhanging that's not gripped, it will catch in the cutter and break the cutter. It'll be a nice bang and you'll wonder what's happened. It's happened to me a couple of times in the past, so I thought I would stop it short. It was about 20 thou thick, didn't take much breaking off, but saved me a cutter. Anyway, now to finish this, the compressor. Okay, that's the last operation on these nuts, is to take them down to thickness. Using the insert end mill, 3000 RPM, about 6 inches, well 9 inches in the speed. It copes with it really nicely, it makes a lovely job of it. Okay, just a quick update on these T-nuts. There's a finished article, machined on every face. I dressed them with a file to clean the rags off. I could have used some kind of program to chamfer them, but I didn't see the necessity for that. One thing that amazed me was that I'd never cut threads using thread milling before, and I thought it may be difficult. You know, you might have some messing around to do to get the thread correct, but in the vise is one of the long bolts of my clamping set for one of my well, for my manual mill, and you can see that the nut is quite a good, in fact it's an extremely good fit. There's no slop in that whatsoever, and that's straight off the machine. I'm so pleased with that. That is a fantastic result for a first time, and hopefully it'll stay that way.